Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Loopy Circles by Skojo. And here are the rules. We have normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and 3x3 box. We also need to draw a 1-cell wide loop through the centers of some cells. The loop only moves orthogonally, which means horizontally and vertically, and cannot branch or touch itself, even diagonally. So that means every cell on the loop must share an edge with exactly 2 other cells on the loop. So, and if it shares a corner with a cell on the loop, it must be either a neighbor or share a neighbor. So, for example, this is a valid example of a loop here because every cell on the loop shares an edge with exactly 2 other cells on the loop. And if it shares a corner with another cell on the loop, they must be neighbors, which these 2 are, or they must share a neighbor, which these 2 do. This is not a valid loop here. Actually, I guess we could just do that and then go here. This is not a valid loop because they would be sharing a corner here, and they don't share a neighbor, and they are not neighbors on the loop. So that's an example of how an orthogonally connected loop works. A digit in a circle on the loop indicates how many circles on the loop contain that digit. Similarly, a digit in a circle off the loop indicates how many circles off the loop contain that digit. So, for example, if this were, say, a 5 here, that means there must be 5 other digits on the loop which are in the circles. Yeah, so this would be potentially valid. So you have 5 5s in circles which are on the loop. Similarly, say you had, well, this can't be in a 1-to-2 ratio, but say you had a 4 here off the loop. That means there have to be 4 other circles off the loop which contain a 4. Which actually this wouldn't be valid, but say like that. Then this would satisfy the circles off the loop. And those are examples of how circles work on and off the loop. We also have black dots separate digits where one is double the other. And additionally, exactly one cell touching a black dot is on the loop and the other is off the loop. So this satisfies here because we know this digit, one digit is on the loop and one digit is off. So this would be valid here. And it doesn't work as a numbers though. So say this was a 4 here. This would have to be a 2 or an 8 to maintain the 1-to-2 ratio between them. Or basically one is double the other. White dots separate consecutive digits. And additionally, the 2 cells touching a white dot are either both on the loop or both off the loop. So this would not be a valid example of a loop then, because one of the digits is on, but what the other one is off, and that's not allowed. You can either have them both off or they're both on, and I don't think I have any examples where they're both on. But say this was a 5, this would have to be a 4 or a 6 to make sure that these digits are consecutive. And not all dots are necessarily given. So those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. How many circles do we have? We have 9 plus 6, that's 15, plus 5, that's 20. 4 is 24. 6 is 30. 4 is 34. 5 is 39. 4 is, no, not 4, 5. So 39 plus 5 is 44. Plus 9 is 53? Is that right? Okay, so let's double check. Let's count this in columns then. 9 plus 5 is 14. Plus 5 is 20 is 19. Plus 5 is 29. No, 24. So 9 plus 5 plus 5, that's 10. Plus 5, and that's 6. So this is 11. So 10 plus 20 is 30. This is 35, 40, 44, and plus 9 is 53. So yeah, 53 circles. Now the thing is, 5, 6, 7, 8, 9 cannot be in both sets. You can only have 5, 6, 7, 8, 9 either be all in circles off the loop or all in circles on the loop, right? Because if you try to have them in both sets, so say you try to have 5 on the loop and 5 off the loop, that would mean that you have 10 5s, which we can't have in a normal Sudoku puzzle. So 1 through 4 can be duplicated. And in fact, because we know we have 8 extra circles, so we have to have, because all of row 1, column 1, row 9, and column 9 are filled with circles, every digit is in a circle. We know that means there are at least 45 circles. And we have an extra 8. To add up to those extra 8, we have to have 3 digits, or we have to have digits which sum up to 8, adding up. And the only possible combination would be 1 through 4, so it has to be 1, 3, and 4 are doubled. So 4 has to have 8 circles having a 4. 9 obviously has to have 9 digits having a 9. 9 circles having a 9. 8 has to have 8. 4 has to have 8 fours in a circle. 3 has to have 6 cells in a circle. 1 has to have 2 cells in circles. So that means 1 and 2 both have two digits in circles. 3 has to have 6. 4 has to have 8. 5 has to have 5, obviously. 6 has to have 6. 7 has to have 7. 8 has to have 8. And 9 has to have 9. Okay. So what does that mean? We need to have... So 1 and 2 have to be in the corners, period. Because you can only have 2 of each in circles for 1 and 2. And if you don't have them in the corners, that means you're going to have 1 in this row or column. That means, say you don't have 1 and 2s, at least one of the 1 or 2s is not in the corner. One of the 1 or 2s has to be here, but that leaves 1 or 2 having to be here, and then 1 or 2 having to be here. And that obviously doesn't work because, again, 1 and 2 can only be in 2 circles each. Right? So this has to be a 1-2 pair in the corners. This cannot be 1 because that would force this to be 2 to be in a 1-to-2 ratio with it. So this must be 2, and this must be 1 because of it. This is 1, and this is 2. 2 has to be consecutive with 3. 2 has to be in a 1-to-2 ratio with 4. So 2 is either on the loop or off the loop. We don't know which. One has to be... we do know this one. Okay, so for a black Kropke dot, 1 is on the loop and 1 is off the loop. If the 2 were on the loop and the 4 were off, that would not work. because this 2 wouldn't have anywhere to go. Remember, every digit that's on the loop must share an edge with exactly 2 other cells on the loop. So the 2 cannot be on the loop here. That means the 2's are never on the loop. The 4 here has to be on the loop then, and it must go this way. So this cannot be on the loop because it would be touching itself then. 2 is not on the loop here, and if you have a white dot, both digits touching it are either both on or both off the loop. So this is off the loop too. One of these is going to be on the loop. We don't know which. Okay. Can this white dot be both off the loop? I think the answer to that is no. If this is both off the loop, one of these has to be on the loop. So if it tried to go on the loop here, the problem is these would both be off the loop. And then it would be stuck here, right? So this would be on the loop, this would be off the loop. How does it exit out? It can't and be a loop. So that doesn't work. If this is off the loop and these are on the loop, the problem is, again, it gets stuck here too. So this has to be on the loop, period. So this is on the loop here, which means it either goes this way. So can it? It either goes this way, which it could. This is only on the loop if it connects this way. But the problem is, okay, so if this is on the loop, it would have to connect here, but then this would be considered branching, which is not allowed, or touching itself. So this cannot be on the loop. That means these two must be on the loop. They must share an edge here. Oh, sorry, they share a corner, so they must share a neighbor. This has to go this way. It cannot go, it could go here. That's fine. This has to exit out here. This could go here. One and two in the rest of... So 2 has to be one of these 2 cells, right? Because 2 cannot be outside in a circle anywhere else besides these 2 spots. Same with 1. So this has to be 1 here. Where is the 1 then in row 7? Cannot be here because of 1 has to be, can't be in a circle. Can't be here because 1 in the box, so 1 has to be here. Similarly, 1 is here. 1 has to be here. 1 is one of these 4. We don't know which. 2 is one of these 2. 2 has to be... Okay, this has to be a 1-2 pair here. Because 2 cannot be in any circle here either. So this is a 1-2 pair here, which eliminates 2 from this cell. So this must be 2 here, which is consecutive with 3. What else do we have? 4 can only be outside a circle in... So again, we have 2 1s and 2 2s on the loop, on the circles. And we already have that. 5 can be 5 circles on... 6 can be 6 circles. 3 can be 6 circles. 1 and 2, this is consecutive with 1, 2, or 3. This cannot be a 1 or 2 on this, in this circle, because we already have the 1s and 2s accounted for. So this is 3, which makes this 2, which makes this 1. So 1 cannot be here, which means 1 is one of these 3. 2 cannot be here. 2 is one of these 2 digits here. So 2 has to be one of those 2 digits there. 2 cannot be here, so 2 is one of these two digits. 2 is one of these 4. Okay. This cannot be 3 and 6 in a 1-to-2 ratio. This has to be a 4-8 pair. So this is 4-8. This then has to be 2-4-8 here. This becomes a 4-8 pair, which means the remaining digits in the row cannot be 1, 2, 4, 8. So we have 3, 5, 6, 7, 9. This can't be 3 because of the 3 in the box. This is 5, 6, 7, 9 here. This cannot be on the loop because it would be considered touching itself because they would be sharing an edge. And this has to connect to one of these two. So if we try to connect this way, this doesn't have a edge to connect to, so this doesn't work. So this cannot be on the loop. 3 cannot be here because it would be consecutive with 2 or 4, but we already have a 2 or 4 in the box. These are 5 through 9. So this can't be 3. 5 is consecutive only with 6 here. 6 is consecutive with 5 or 7. 7 can be consecutive with 6 or 8. 9 can be consecutive with 8. So those are the possibilities there. These are both either on the loop or off the loop. We're not sure which. These could be both on the loop or off the loop. One of these two cells is on the loop. These digits are 4 through 9. Four is guaranteed to be one of these two digits here. Oh, this is a 4 off the loop, which is the only 4 that can be off the loop. And it's in column 2. Sorry, not off the loop. Not in a circle. Apologies. So that means 4 has to appear in columns 1, 3, 4, 5, 6, 7, 8, 9. 4 has to be in a circle. Okay, these digits are consecutive. It cannot be... This could be 3 here, 4, and 5. 5 can be in the middle with 4 and 6. 6 can be in the middle between 5 and 7. 7 can be in the middle between 6 and 8. And 8 can be in the middle with 7 or 9. Okay. These are in a 1-to-2 ratio, and you can't have 2 and 3. This has to be a 4-8 pair. That eliminates 4 and 8 in the rest of the column. Okay. 4 is consecutive with 3 or 5. 8 is consecutive with 7 or 9. Okay, so those are there. This is a 1-to-2 ratio. So it could be 2 here, 4 here. Could be 4 and 8, or this is 3, 6. We don't know which. 4 is already here in column. This cannot be 4, because again, this has to be a 4 here. It's either 2, 4 or 4, 8. So this cannot be 4 here. So this can't be, still could be 3, 4, 5. Okay. Four has to be one of these digits here. 4 has to be one of these 3. 4 has to be one of these 4 here, or these 3 here. Hmm. If 1 is on the loop here, it would have to go through here and then go that way. So then this would be on the loop. Okay. Oh, where's 2 in row 5? Can't be on the circles. Can't be here because of 2 in the column, so it has to be one of those 2 digits here. Okay. This cannot be on the loop because... Wait, why? It doesn't have to go that way. Why did I do that? It just goes that way. Oh, no, because... yeah, there has to be... In every black dot, one cell is on the loop and the other is off. So this must be the on loop. So this can't be on the loop then. These are both the same set. This is a different one. So these are both either on the loop or they're both... they're both off the loop. Oh, this 4-8 pair eliminates 4 and 8 in the rest of the box. So this could be 3, 4, 5. It cannot be 4, 5, 6 here. Because 4 can't be here and 4 can't be here. Also, this can't be 4 either. So this can't be 5 here, right? You would have to have 4 and 6 on the outside, and that's not possible there. You could have 5, 6, 7 either way, 6, 7, 8 either this way specifically, 7, 8, and 9 either way. So there is that. We are guaranteed 2 of the... 2 of 5, 6, 7, 8, and 9 are at least on the loop. We don't know how many we have on the loop. We know we have 1 off the loop. Oh. It has to be 2 off the loop and 2 on the loop. Right? This is guaranteed to be off the loop. Oh, wait, no. We don't have anything with this. So, at least 2 are on the loop, and at least 2 are off the loop. We don't know about the third. The third could be on or off the loop. So what you cannot do is you cannot have all of this being that way. Because this cell has to be off the loop, so it has to be one of these 2 cells. And, well, it could be that one, I guess. But it can't be 9 here. So if this were 9, 9 is always in a circle. And it's off the loop. It would have to be 9 here off the loop, which would mean it would have to be one of these 2 cells. But 9 would be not in a circle there. So this cannot be 9 here. We're guaranteed one of these 3 is a 9. Oh, this can't be 9 because it's off the loop. Or, sorry, it's not on the... It's... I keep getting that confused. It's not in a circle. Okay. 3 is in a circle here, 3 is in a circle here, 3 is in a circle. Where's 3 in box 4? It has to be one of those 2 digits there. These are 2 cells. This could be all 3 cells that are on the loop. Or it could be 2 cells. We're guaranteed one of these is not on the loop. So because we know there are at least 2 cells that are not on the loop, and this is because of box 1, right? It either has to go that way on the loop or this way. Either way, there's going to be 1 on the loop and 1 off the loop here. Guaranteed from 5, 6, 7, and 9. So because of that, one of these has to be off the loop. And we know these are off the loop, so it can never go in 1 here. It can't even be 2 going in here. So these 2 are off the loop. We still don't have any guaranteed there, though. Okay. Right. So there could be a 4 somewhere here. That's the problem. We don't know where the 4 is. So again, out of the digits 5 through 9, 2 of them are definitely on the loop, 2 of them are definitely off the loop, and we don't know what the last digit is, whether it's on or off the loop. Sorry, 3 of them are in circles on the loop. Sorry, 2 of them are definitely in circles on the loop, and 2 of them are in circles off the loop. We don't know what the third one is. These digits are consecutive. Cannot be 1, 2, and 3 is not possible because of the 3 in the column and the 3 in the box. So this is 4 through 9 here. Um, uh, so if it goes this way, okay, so this cannot be on the loop. That could be, actually. It could go that way. That's possible. Never mind. One thing is, so then, okay, so this can never be going that way on the loop. It could be 1, 2, 3 that way and going there. So can this ever be on the loop? If this is on the loop, the problem is it can't go that way. It would have to go this way. But then we have 4 cells, 4 digits from 5 through 9 on the loop when we know there's 2 at least that are not. So that does not work. So it cannot go this way. It has to go this way. So this is not on the loop. This is not on the loop. Sorry, this has to be on the loop. There we go. So it enters in this way, it must exit out this way, so this cannot be on the loop. Therefore, this is on the loop, and this is not on the loop. So it has to go this way. Okay. So this has 2 digits which from 5 through 9 not on the loop, and this is 3 digits from 5 through 9 on the loop. So this must be off the loop. That means this cannot be 4 here, because we have 3 digits in this column which are on the loop, but it must be from 5 through 9. So this has to be not 4. This is 8, which makes this 4, and then this can't be 4 here. This is 2 or 8. So that means 8 is on the loop. So 8 cannot be here, which means 8 is one of these 2. This can't be 4 again, because these 3 digits are the same digits as these 3, which are on the loop. These 2 digits are the ones that are off the loop. This then has to go this way. 4 is both in one of those 2. So this is 2 or 8. That's fine. 4 is one of those 3. 4 is one of those 3. We're not sure which. 4 has to be in circles now. So it's one of those. Oh. Where is 4 in box 5? It has to be one of these 2 digits then, because it can't be here because of the 4-8 pair in the column. And yeah, actually, what are the digits remaining in column 5? We have 1, 5, 6, 7, 9. 1, 5, 6, 7, 9. This can't be 1 because it's in a circle. This can't be 1 because it's in a circle. 9 cannot be outside the circle. So 1, 5, 6, 7, 9. If these are both in a circle, I guess it could be that going that way. It has to go this way though, if that's the case. So if these are if these are both on the loop, it has to go to here, and then all of these are on the loop, which means these 2 have to be off the loop and are the 2 missing from 5 through 9. Interesting. So this is not on the loop. So it would have to do something like that, which is possible. This is a 4 off the loop in a circle. We have a 4 on the loop on a circle, 4 on the loop on a circle. So this cannot be 4 here, and it cannot be 4 here. Where is the 4 in box 4? It has to be in a circle, and it can't be any of these cells, so this must be a 4 here, which means this cannot be 4 here. So 4 in column 3 then has to be one of these two cells, because it must be in a circle, because this is the only 4 that's off the circle. This is 4, so 4 has to be one of these two. 4 has to be one of these 4. Eight is always on the loop in a circle. Oh, that's interesting. So whichever 8 is here, it's always on, well, it's always on the loop. That means the 4 has to be off the loop, wherever it is. Huh. Interesting. What else do we have? 3 must be... Okay, so where are 3s in circles? It's here, 1, 2, 3. It has to be here, that's 4. We don't know if it's here. We don't know if it's here. We don't know if it's here. So that's not helpful. Never mind. Okay. Can this ever be on both on the loop? I think the answer to that is no. So if these are both on the loop, how does this this has to connect to this to be a neighbor, but then this has to be the neighbor, so then it can't go that way and it would branch. So this cannot be on the loop, which means it does go this way. So this could be the 3 here. So this is not on the loop. We have 2 digits not on the loop. So this cannot be 5, 6, 7, 8, 9. Or 5, yeah, cannot be 5, 6, 7, 8, 9 because we have a 4 here and 3 of the other ones have to be on the loop. So this must be a 3 here, which eliminates 3 in the rest of the row. That means where's 3 in box 3? It has to be here. So this is a 1, 3 pair. And this is 4, 5, 6, 7, 8, 9 on the loop. We have 3 digits on the loop here. We need another digit that's off the loop. So this has to be off the loop, which means this is off the loop. So this must go that way. Okay, this can't be on the loop because it would be touching itself there. So this must continue on there. We do have to go somewhere here because we need to be on the loop somewhere along here. Oh, these are 2 digits which are off the loop. It cannot be 8. So this can't be 8 and 9. So the 2 digits off the loop have to be 5, 6, or 7. And one of them is 6. Because those digits are off the loop. So 9s have to be on the loop. So this cannot be 9. These can't be 6. So 6 is guaranteed to be off the loop, but we don't know where. That means this can't be 6 here. This can't be 6 here. This can't be 6 on the loop here. So this is guaranteed to be 6, so this cannot be 6. This is 3 or 4, which would be next to 2, 6, or 8. You could have 3 going that way, and going that. You could have going that way. You could have it all going there. That's fine, too. This is not on the loop. Okay. We have a 5, 6, 7 triplet in row 3, which eliminates 5, 6, and 7 in the rest of the row, so this must be 9. Which means this can't be 9 here. 9 has to be one of these 3. 9 is obviously one of those 2. So 9 cannot be off the loop here. And this can't be 6. So 9 is one of these 2. So this digit is not 6. It's the other digit which has to be in a circle on the loop. Which I guess would be that one. But we don't know which, though. 9 has to be one of these 5. 9 is either here or here. Okay. So 9 has to be one of these 3 cells here, and therefore it's on the loop. Because there's no other place for it in row 7. Oh, where is 9 in row 8? It has to be one of these 2 digits, so this cannot be a 9 here. So 9 is always on the loop. 8 is always on the loop. 6 is never on the loop in a circle. Yeah, 9 and 8 are on the loop on a circle. 6 is never on the loop on a circle. 5 and 7 could be, but we don't know. This is interesting. So it could be all 5 of these are on the loop. Oh. Say these were all the 5 through 9s, right? That are on the loop. If that were the case, it would have to go this way. It could still go there then. It could go there also. Well, okay, say it tried to go this way, essentially. I think the answer to that is it can't. Yes, because then these would both be off the loop because it would be considered touching itself. So it cannot go here and then go that way. It has to dip into one of these 3. At 2 out of these 3. Because this is 3 or 4. It cannot be 5 through 9. And the reason why we know that is it can't be it can only be 6 here or 8 here as a high digit. And 8 would force us to be 4, which we can't have because we have a 4 in the column. 6 can't be here because one of these is 6 here. Oh, this is a 5, 6, 7 triplet, which eliminates 5, 6, 7 in the rest of the box. So this is 8, which means this cannot be 8 there. So we have to enter 2 out of these cells at least. It cannot go just out again. So it can't be like that. So I think this is always on the loop. It could enter that way possibly, or it could enter this way. But it can't... At least 2 of these are on the loop. And it could be all 3. So this is definitely on the loop. And I think this is definitely on the loop. So it can never go here and then exit back out because it would be touching itself. So if it goes that way, it has to go here. It has to have 2 at least here. So this is definitely on the loop. And again, we cannot go this way and then exit back out here because then neither of these would be on the loop, and we know one of them has to be. So then this one must exit out that way. So this is not on the loop. It must go that way then too, which means it goes here. So these are not on the loop then, because they're either both on the loop or both off the loop. This has to go either here or here, so these are not on the loop either. This can... what can this be? This can't be 2 or 1. If we try to have a 3 here, the problem is this would have to be 2 or 4, and it can't be 2 because we know the only 2 in row 5 has to be one of these 2s. It can't be 4. So this has to be 5, 6, 7 as possibilities because it's off the loop here. That means this is consecutive with 5 through 8. 9 is definitely one of these 3. Because it cannot be either of the cells that are off the loop. And we know 9 is always in a circle, so this cannot be 9, which means this has to be 9 here, and it has to be on the loop. So this is on the loop. This is off. It has to either, well, it could do something like that. It could go something like that. It could do something like that. We don't know. 9's one of those 3. 9 has to be one of these 3 and on the loop. 9 is one of these 3 and on the loop. So 9 must be either here with 8, or 9 has to be one of these 2 with 8. So I think this is always on the loop, right? 9 always has to be on the loop. It's either here with 8, and that would be on the loop, and then it would have to go this way. Or it's one of these 2, which means it's on the loop here. So this is always on the loop here, which means it must come in from that way. This is not on the loop. This must go that way then. I guess this could still be on the loop, going that way. That's possible. So this goes either here or here. We're not sure. And then it goes there, if that's the case. One of these 3 is on the loop. Okay, this is not on the loop because it can't enter in there and then exit out. This cannot exit out this way. because it would have to be touching either that which is on the loop, or it's already touching this cell on the loop. So it cannot go this way. You could technically, though, do something like that. No, this is not on the... this either... I guess it could do like that. That's possible. Or it could go like... it can't... Can this ever be a 9? It would have to be on the loop then. So it cannot go this way to go on the loop. So it would have to be from this angle. And then the problem is it would be touching itself there, and then it would be touching itself there. So this can never be the 9. Technically, either one of these two was a 9. Don't know which. So I think this always has to be on the loop. If this is the 9, how do you enter and exit? This green either goes this way. Can it actually do that? I guess it just has to continue on here. So can this ever be 9? Is kind of the question. I guess it could go that way. In which case, yeah, that could be 9. It could be like this, right? That is possible. Okay, so this is not on the loop. But this could be both of these not on the loop. And it could be 3 and 4, essentially, not on the loop, right? It has to be 4 off the loop here. We know that for certain. Okay. What else? This is a 5, 6, 7, not on the loop. But we don't have any other real information there. One of the ones is there. But that doesn't really help us much. Oh, if one of these is on the loop, the other one is. Can this ever be not on the loop? So if this is not on the loop, this can't go this way. This would have to go that way. And then this would be a 9, which would have to be on the loop. Which doesn't work, because it then touches itself here. So this has to be on the loop. Which means it goes to one of these two. It cannot go here, because that would be on the loop. So this does not on the loop, because again, it goes to one of those two. This is not on the loop, because it goes to one of those two, then to here. And then it has to go here, because both of them have to be on the loop. Which means this has to go here, and then it goes here. So this is not on the loop here, because it would be considered touching itself. So this is not on the loop. And these must be on the loop. And we know we have to have 2 digits not on the loop from 5 through 9. So this has to be not on the loop, and it's not a 4. So these are digits 5, 6, 7, and one of these is a 6. So because one of these is a 6, this cannot be 6 here. This can't be 6. So this is either 7, 8, 9, or 3, 4, 5. So this could be 3, 4, 5, or 7, 8, 9. So this is a 4, 8 pair here. This is a 4, 8 pair. This cannot be 3 and 6 then in a 1 and 2 ratio, so this must be 4. So this is not 4 here. This is 2 or 8. This 4 eliminates 4 here. Where is the 4 in column 3? It has to be here. So this is 4, which is next to 3 and 5. That forces this to be 4 here. This is 8. This is 8, and it has to be 9 because there's no other place for it. So this is 9, which means this is a 6, 7 pair, not on the loop. So this must be 6 and 7. This is 6 and 7. This is 6 and 7. So this cannot be 7 here. There's a 5, 9 pair here. 5 eliminates 5 here, so this is 9, which means this can't be 9. That's 5. This has to be 5 then. This cannot be 5 or 7 on the loop, therefore that makes this a 9, which makes this a 4, 8 pair here on the loop. This is a 6, 7 pair. So this cannot be 5 here. This has to be 6 or 7. Not on the loop. This 4 eliminates 4 here, so this must be a 4 off the loop. This 5 eliminate. This can't be 5. This can't be 5. This can't be 5 or 7. Therefore, this is 9. So this cannot be 9 here. This can't be 9 here. This has to connect to here. So this is the loop. That means these cannot be on the loop because they would be considered touching itself. So this must go here, which forces this to be a 9. So this is 9, which makes this 8 to be consecutive because this can no longer be on the loop. So none of these are on the loop. This has to be a 4 because there's no other place for it in row 5. That means this an 8, which makes that a 4. This cannot be 6 or 7 on the loop, so it has to be 5 here. We have 4 5s. That means we need an 8. This 8 eliminates 8 here, so that's 2, which means this can't be 2 here. 2 has to be one of these 2 here. We need, well, 8 doesn't have to be here. 8 is one of these 2 digits there. This cannot be 9. So where is the 9 then in column 9? It has to be here. Which leaves, this has to be a 9 because that's the only place for it in just normal Sudoku. Okay. This cannot be 8 or 9 or 4. We have a 3 here on the loop. 3 here. Okay, so we have 3 of the 3s in circles not on the loop. This could still be 3 here. I don't know why. I just eliminated that. Let's just look at the remaining digits in... This cannot be 6 or 7 on the loop. It can't be 3, 4... Okay, so the digits, digits in circles on the loop left are 3, 4, 5, 8, and 9. This can't be 3, 4, 5, or 9, so this has to be 8. Which means this cannot be 8. This has to be a 1 with a 6 or 7 here. That means 8 is here, so 8 is here. So this cannot be 8 here, so that's 2, which means this can't be 2, and this can't be 2. That forces 2 in row 5 to be there. We know 8's one of these 2 digits here. Okay, 8 cannot be in a circle in box 5 because again, this is off the loop. So 8 always has to be on the loop. That means 8 in box 6 has to be on the loop in a circle. So this can't be 8. So this must be the 8 here and it must be on the loop. So this is off the loop here. That means this can't be 8 here. Where is the 8 in row 8? It has to be here. So that's an 8. We should have... Yes, 8 cannot be here or here or here. So this must be 8 here, which means this can't... This is the guaranteed 2. So this cannot be 2 here, so this is 2 there. This has to be 6 or 7. Circles, this has to be a 3-5 pair left in column 9. That should be all the 3s and 5s left over. One of these is guaranteed to be 3. Oh, this 3 eliminates 3 here, so this is 5, which makes this 3. That forces this to be a 3 here. This can't be 5. This is a 1, 6, 7 triplet. That means this has to be 6 or 7 also here. This is 1, 6, or 7. 5 cannot be in a circle off the loop, so this is 6 or 7. We have a 6, 7, 6, 7 pair, which eliminates 6 and 7 in the rest of the row. This can't be 8 anymore, so this is 5. 5 is consecutive with 6, so that's 6. This is 7. 6 eliminates 6 here, so it's 7, which makes this 6. 7 eliminates 7 here, so it's 5. Remaining digits, this can't be 3 anymore, so that forces 3 to be here. This makes this 1. So this can't be 1 here. Where is the 1 in box 7? It has to be here. This has to be a 6 or 7. Therefore, it cannot be on the loop. So this must be the other cell on the loop. And this is not on the loop. This can't be 6 or 7 because of the 6, 7 pair in the row. This is 1 or 5, cannot be 5 because of the 5 in the box, so this is 1, which makes this 5. This 7 makes this not 7, so it's 6, which makes that 1. 6 eliminates 6 here, so it's 7 and 6. This can't be 6 or 7, so it's 1. This can't be 1. This has to be 7. This 1 eliminates 1 here, so it's 3 and 1. And now this has to be 5. So we should have 1, 1 in a circle on the loop, 1, 1 off the circle on the loop, 2 2s in a circle, in circles off the loop, 3 3s in circles on the loop, and 3 3s in circles off the loop, which it is, 4 4s in circles on the loop, 1 2 3 4, and 4 4s in circles off the loop, 1 2 3 4. 5 5s in circles on the loop. 1 2 3 4 5. This is not on the loop. 6s, we have to count. 7s. 8s. Should be 8 8s in circles on the loop. And 9 should have 9 9s in circles on the loop. So... there's a pair here, there's a pair here. We have how many 7s? So this is a 7 off, not in a circle. This is a 7 not in a circle. So that means the other 7 have to be in circles. So this can't be a 7. This is 6, which makes this 7, which makes this 6, 7, 6, 7, which makes this 6, that's 7. This 7 eliminates 7 here, so it's 6. And then that's 7. And that should be the solution, which it is. Very cool, actually. Interesting logic that this is required. Yeah, it's just the geometry of this was very fascinating about what you can and cannot have on the circle. Sorry, in a circle, on a loop, or off the loop, right? And then we just, yeah, you always have to count circles, I feel, at the very beginning, because that gives you a baseline for everything, which you can build off of. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.